Hello everyone, myself Dharna Swapna. I am working as Assistant Professor, Department of Freshman Engineering from St. Martin Engineering College. Today, I want to discuss about types of polymerization, and before going to this topic, I want to discuss about some terminology like here, all different types of polymers we are using in our day-to-day life, isn't it? Here, some of the examples I gave you. This is the polymers where we are using as the materials. See here, this is the bottle, chairs, plastic, and the shoe soles. These are the some of the examples where we are using into day-to-day life. Then, what is the polymer? Polymer, it is nothing but a large molecule which is composed by the small units. Here it is one of the monomer, that is the vinyl chloride. Here by this is one the small unit which is going to repeated in the polymer. Okay, then here it is the monomer where the repeating unit it is called polymer. Then what is mean by monomer? Monomer, it is nothing but a small unit which is repeating in the polymer, then that is called monomer. Here it is the monomer, then this monomer, it is going to combine each and everything and form a large molecule, then that is called a polymer. And which one is the smallest unit, then that is called a monomer. Then come to the topic, here it is the polymerization. Polymerization, it is nothing but where this is the one type of process you can prepare the polymers. How you are going to prepare? Here it is the one of the example, that is the ethylene. Ethylene, on polymerization you will get the polythene. Then here monomer unit, it is nothing but a ethene. Then that is the ethene CH2 double bond CH2. CH2 here and double bond CH2. Here it is a monomer and form a large molecule, that is the polymer. Then another one, it is the polymerization process. In this, there are the two types of polymerization process are given. First one is the addition polymerization and another one is the condensation polymerization. Let's discuss about the addition polymerization. This is also known as chain growth polymerization. What is the addition polymerization? Addition polymerization, it is also known as a chain growth polymerization, as here the smallest unit it is going to add every time, and without removing any byproduct you will get the end product, then that is the polymer. Then this process it is called addition polymerization. And here, to prepare the polymers in this addition polymerization, we required light and heat. Then, and along with the catalyst we are using here. Then see here, this is the one of the addition polymer where initially the monomers they are breaking and making a bond with other molecules. Similarly, think about each and everything, it is the monomer, and due to the breakage of the bond, then it is going to combine with the another molecule and form a large molecule. Okay, then this is the joining together, monomers they are joining together and form a polymer, then in the presence of light and heat along with the catalyst. Then these are the examples of the addition polymerization process. In this, monomers are ethylene, and after the polymerization, addition polymerization, then you will get the polythene. Another reaction it is styrene. Styrene, through the addition polymerization, you will get the polystyrene. Similarly, we can prepare polyvinyl chloride. Okay, and here this is the mechanism. where the mechanism of addition polymerization, here there are the different types of reaction mechanisms are given. One, it is the free radical reaction mechanism of addition polymerization, and another one it is the cationic addition polymerization reaction mechanism, and another one is anionic addition polymerization reaction mechanism. Then we will discuss about the free radical reaction mechanism of addition polymerization. Then here there is a free radical reaction polymerization. There are the few steps are involving in this mechanism. Then why we have to learn this mechanism? Because of here, after producing the compounds, then how it is going to bind with every molecule, that is we have to know that. Okay, then that's why we should know about the steps that is involving in the mechanism. Okay, then here it is the steps that is involving in the mechanism. First one is the chain initiation, then second one is the chain propagation, and third one is the chain termination. Chain initiation step, that is nothing but where the reaction it is going to start. Reaction it is going to start, that means here we are using the catalyst to initiate the reaction. Initiate the reaction, to start the reaction. Then that is called a chain initiation step. Chain initiation step. Then second one is the chain propagation step. Chain propagation step, it is nothing but where one after one the monomers, they should combine with the free radicals or ions. Okay, then they can form a large molecule. Then that step it is called a chain propagation step. Then third one it is then chain termination step. Termination means end of that. Okay, then here if we want to stop the reaction, the molecular weight, think about the initial monomer, the molecular weight it is 100. Okay, then next one, if you want to prepare only 10,000 molecular weight contains polymer, then what happen here? Then we have to stop the reaction. If you are adding more amount of monomer, it is also, then it is going to combine. But we need only 10,000 molecular weight consist polymer. So we have to stop the reaction. Then that step it is called a chain termination step. Here, how we are going to prepare the polymer? Then that is the polymerization. One of the reaction it is ethylene. Ethylene, that is a C double bond C with two hydrogen, okay, and here this carbon with also two hydrogen. Then here in the presence of sunlight and catalyst like peroxide or phenyl peroxide, benzoyl peroxide we are using here, benzoyl peroxide. Okay, benzoyl peroxide, or otherwise we can write it in the expansion form pH C double bond O O O C double bond O pH. Okay, then this is the one of the catalyst where the name it is benzoyl peroxide. Now in the presence of sunlight, it is ethylene, it is going to polymerization and form a polythene. It is going to form a polythene. Then this is the one of the example where see whatever the catalyst we are using here, these are only initiators. These are only start the reaction. Then this is a addition polymerization. And another one, to start the reaction, another component we need, that is the light or heat. Here it is given the temperature, it is about 350 to 570 Kelvin. We can use, or otherwise we can use the sunlight also. Then come to the steps that is involving in the free radical addition polymerization reaction mechanism. Now, as I told you, there are the three steps are involving in this mechanism. First step, we discuss. First one, it is the chain initiation step. Here it is the chain initiation step. That means we have to use any catalyst in the presence of light. See, these are the some of the example it is given. That is the initiators, that is acetyl peroxide or benzoyl peroxide or azo compounds. Azo compounds, it is nothing but N double bond N. Peroxide compound means oxygen single bond it is present. These are the weakest bond. They can form radical in the presence of sunlight. So that this type of initiators we are using here. Now let's discuss the chain initiation step. Now, in the chain initiation step, first initially we are using the catalyst, that is the benzoyl peroxide. As I told you, benzoyl peroxide, it is at pH C double bond O O O C double bond O pH, isn't it? Now, in the presence of sunlight or temperature, this bond it is going to homolytic cleavage. Homolytic cleavage, that is, here it is, then two radicals, two electrons are present, then that is going to homolytic cleavage. Now we will get pH C double bond O O radical. Now this is also unstable one. Unstable one means here it is again these two electrons, it is undergoing homolytic cleavage, and again you will get the radical. Radical means pH radical with carbon dioxide. Now this is only the initiator. This is only the start the reaction for the polymerization. Now come to the monomer. I am taking here one of the monomer, it is the ethylene. Okay, ethylene. Now, because of the presence of benzyl, that is that benzene with radical. Now, this bond it is going to break. Now, this bond it is going to break means here it is homolytic cleavage in the presence of sunlight. Then radical, again you will get CH2 radical with CH2 and a pH. Now, this is start the reaction. This is going to start the reaction. Then this step, it is the first step in the mechanism, that is the free radical reaction mechanism, chain initiation step. Okay. Then second step, it is chain propagation step. Okay, now we will discuss about the second step, that is the chain propagation step. In this chain propagation step, whatever you got in that first step, that is the chain initiation step, now we are going to add the monomers. Here it is that first step, product, it is pH CH2 radical, phenyl radical with the monomer. And here another monomer I am taking, ethylene monomer. Ethylene monomer, then we will get pH CH2. Again this bond it is going to break through the homolytic cleavage and form another molecule combined with that is the CH2 radical. Now instead of writing every time that ethylene, we are writing initially here CH2 that product, and N plus 2 number of monomer, that is the ethylene. Ethylene. Now going to combine this each and every monomer, it is going to break and form a bond, long chain, that is N number and CH2 radical. Okay, then this is the chain propagation step. This is the chain propagation step. See, here already we took two monomers. Okay, then there is the formation of the chain. Now next it is going to combine and form a long chain. Now this is enough for the reaction. If you are thinking this is the enough for the reaction, go to the chain termination. That is the third step that is involving in the mechanism, that is the chain termination. In the chain termination step, we have two steps, that is the coupling of radicals and another one it is initiators we are going to add. Then coupling, it is nothing but think whatever you got the chain propagation step, the product, 2 or more than 2 if it is present. Okay, 2 or more than 2 if it is present, then they are going to couple with each other. Now this is a one and another one it is pH, CH2, CH2 and this is the radical. I took two products and because of these two are the radicals, they are active, they are actively participating in the reaction and form a long chain. Okay, then we can stop the reaction. How we can stop the reaction? These radicals are not at all present in the product side. Okay, now this is the coupling one. And another one is the initiator inhibitors. Initiator inhibitors, these are the compounds where it can be donate hydrogen. Okay, where it can be donate the hydrogen. Think about here I took the benzene. Then now this benzene, it is going to give the hydrogen radical to the product which we got in the chain propagation and you will get the end of the polymer. Okay, this is going to directly donate and make a bond. Then you will get the last product, that is the polymer. This is the last polymer. See, here we discussed about the three steps. First one is the chain initiation step. Then third one it is the termination. First one, here it is the chain initiation step. Now we got the radical. Then second step, it is the chain propagation step. Here each and every monomer that is going to combine. Third one, it is the chain termination step. In the chain termination step, here we have the two different steps. First one is the coupling reaction and second one is the inhibitors. In this coupling reaction, where this component, whatever we are got in the chain propagation, it is going to combine with another molecule and form a long chain polymer. Okay, then here we can stop the reaction. The next one, it is a reaction with the inhibitors or initiator, then where this are going to donate the molecule, that is a hydrogen radical, to the reaction. Now let's see the video where we can prepare the polymer. Here it is, one of the reaction I'm showing here, that is the polyethylene. Polyethylene, in that monomer it is the ethylene. Then this ethylene, it is a monomer where the double bond it is present between the carbon and carbon. Okay, now this carbon and carbon bond you have to break. That means we need that one of the compound, that is the catalyst, where it is can be acts as a initiators. Now this is the benzoyl peroxide where the bond it is going to break, and here it is the oxygen. When oxygen it is a consist of the radical. Now that radical it is making a bond with the carbon, one of that initiation step. Now second one, it is the chain propagation. Now one after one it is going to okay, one after one it is going to bind with the another monomers. See, one of the carbon and one of the carbon, it is going to make a polymer. It is a long chain. Now we have to stop the reaction. Now go to the chain termination step, then another molecule, and here it is another molecule with the radical, you will get the last polymer. Now once recall the topic, that is here. First, what we discuss here, polymers. What are the polymers? Polymers, it is nothing but a long chain unit. Okay, long chain unit, that is a poly means many and mer means unit. And here it is a micromolecule. Okay, then next one, these are the some of the example, vinyl chloride. This is going to combine and form a polyvinyl chloride, and acryl nitride, then that is a monomer combine and form a long chain polymer, that is a polyacryl nitride. Styrene, again we will get the polystyrene. Okay, then these are the monomers where we can prepare the different type of polymers. Polymers, it is nothing but, here it is a monomer one, ethylene, and if it is a chlorine, chlorethene. Okay, and according to the, here it is whatever the components we are using, then you will get the polymer. Then what is the polymerization? It is the process where we can form the polymer that from the monomer. Then here it is the one of the example, beads example also I gave you. Then another one, it is a polymer of different alkene. See, observe here, we have the unsaturation initially in the monomer. Then after that, here the unsaturation it is, we can't see because of that double bond, it is now converted into single bond. Okay, single bond, double bond it is converted into single bond. Now what are the types of polymerization process? Polymerizations, they are again classified into two types: addition polymerization, condensation polymerization. Then we discussed about what is that addition polymerization, and here addition polymerization, that means repeated addition of the monomer with the double or triple bond without eliminating any byproducts. And addition polymerization, here it is a one of the example, we know that. Okay, then this is the double bonds now converted into single bond, and making a long chain polymer. Then mechanism, then here it is the different mechanisms are there. Free radical reaction mechanism, cationic reaction mechanism, anionic reaction mechanism. Okay, then in the free radical reaction mechanism, here there are the few steps are involving. There is chain initiation, chain propagation, chain termination step. Then in the polymerization, one of the example I took, that is the polythene preparation. Here it is a ethylene to polythene preparation in the presence of benzoyl. Here it is given C. Okay. Then this is the benzoyl peroxide. Because of this benzoyl peroxide only it can be may break the bond of unsaturation and we will get the radicals. That's why maximum we are using this benzoyl peroxide or hydrogen peroxide also we can use here. Okay, through the polymerization process we will get that polythene. Then in this mechanism there are the three steps are involved. Chain initiation step. In the chain initiation step we need a radical to start the reaction. So we have this acetyl peroxide, azo compounds or benzoyl peroxide. Okay. Now come to that. Here one of the example I gave you, general example it is RR, it is nothing but where the any initiators we can use. Then the bond it is going to break in between these two. See here, in between these two and you will get the 2R. Okay, now this 2R, it is combined monomer and form a radical. Then you will get the, at the end you will get the phenyl. Another one reaction it is there. This is the general reaction. Then second is one chain propagation, free radical combination of different monomers. They are going to combine. Then here it is, whatever you got the product, combine and form a long chain polymer. To stop the reaction, we will go to the chain termination step. Here it is, two steps are given, coupling reaction and reaction with the inhibitors. By combination of the free radical, you will get the long chain polymer. This is called a coupling reaction. And another one, it is the inhibitor. Then that is inhibitor, we are using here benzene also and along with the phenol. Then free radical, benzene or phenol, that is going to form a bond, that is hydrogen, and radical, that is the unreactive, we can remove it from the polymer. Now I will discuss about one of the example related to the addition polymerization. Here it is, vinyl chloride. Vinyl chloride, that is bond, carbon-carbon bond with CH2, double bond CH2 with the chlorine. Okay, and here hydrogen, instead of ethylene, one hydrogen I am removing here and substitute the chlorine. Now in the presence of sunlight and benzoyl peroxide, okay, here it is the benzoyl peroxide and this is called vinyl chloride. Then here we are maintaining the temperature about 573 Kelvin, and because of this light or sunlight, this bond it is going to break. And form a initiation. Then you will get a polythene. Here n number of molecules we have to take and CH, Cl. This is the N. See, this is n number of monomers we took. That's why we got the long chain polymer, that is a polyvinyl chloride, polyvinyl chloride. Okay, then another example, same, we have to remove from the ethylene one of the hydrogen, write down benzene. Then this monomer, it is a styrene. This is the styrene. Okay, and through the polymerization process, then in the presence of benzoyl peroxide, and you will get polystyrene. This is the one of the styrene, this is the one of the polymer. Understood? These are some of the example which we are going to use in our day-to-day life. All the vinyl plastics are there, no? Then bottles. Then we are using, by using this polyvinyl chloride and polystyrene. And here it is the one of the application part of the vinyl chloride, where in a different ways we can use in the manufacture of the bottles. In the manufacture of the bottles we can use it, or otherwise some of the components like polyvinyl plastics are there, pipes are there. Okay, then in that we are going to use this polyvinyl chloride. Styrene, it is also we are using, but somewhat strong compared to the polyvinyl chloride. See, compare it. Here it is the we learn about the polyethylene, then that is the maximum we are going to use in our day-to-day life. Okay, now another one, condensation polymerization, we will discuss in the next class. I hope you enjoy this session about addition polymerization reaction and their mechanism. Here it is, all the steps, whatever that is involved in the mechanism, we know that. Okay, thank you.